Hello friends, I am Dr. Sirajul Akfelsi. I welcome you in my YouTube channel. Today in this video, I am going to talk about the stereochemistry. You know about the stereochemistry. It is the branch of chemistry concerned with the three-dimensional arrangement of atoms and molecules and the effect of this on chemical reactions. Concept of isomerisms. Berzelius coined the term isomerism. What is the meaning of isomerisms? Isos means equal and meros means part. To describe the relationship between two clearly different compounds having the same elemental compositions. Such pair of compounds differ in their physical and chemical properties and are called isomers. You can see ethanol and dimethyl ether. Now friends, types of isomerism. You can see here the pictorial picture. Isomerisms, structural and stereo. Chain, position, functional, metamerism, tautomerism, ring chain. Isomerism. In stereo, geometrical and optical. Geometric means isomers differ in their spatial arrangement about a double bond. And optical isomers differ in the arrangement of atom in 3D space, which create mirror image of each other. Each substance has mirror image. Here, mirror image concept is different. Now, in this slide, I will discuss about the structural or constitutional isomerism. These differ from each other in the way their atoms are connected. Connection is important here. That is, in their structure, it's 6 types signifying the main difference in the structural feature of the isomers. Chain, skeleton, nuclear isomerisms, positions, functional, metamerism, tautomerism, ring chain isomerism. So, you can see in these examples, N-butene and branch chain means isobutenes. Then N-pentane and different arrangements. In position, you can see ortho, meta and para dichlorobenzenes. In function, you can see ethanol and dimethyl ether, ethanoic acid and methyl methanoates, here aldehyde, here ketones. Now in metamerism, you can see here these have different number of carbon atoms, alkyl groups. You can see diethyl ether and methyl N-propyl ethers. Tautomerisms, you can see enol form and keto form, lactam form and lactim form. This is lactam, lactim. Amide form, imidic, acidic form, amine form and imine form. Stereoisomerism. Isomers which have the same molecular formula but differ in the manner their atoms or groups are arranged in the space are called stereoisomer. It is of 2 types, conformational isomerism and configurational isomerism. The stereoisomers which can be interconverted rapidly at room temperature without breaking a covalent bond are called conformational isomers or conformers, because such isomers can be readily interconverted or they cannot be separated under normal conditions. The stereoisomers which cannot be interconverted unless a covalent bond is broken are called configurational isomerism. That is importance, means formations here is the double bonds. The configurational isomerism is again of 2 types, optical isomerism or enantiomerism and geometrical isomerism. The stereoisomers which are related to each other as an object and its non-superimposable mirror image are called optical isomers or enantiomers. Greek enantiomers means opposite. The optical isomers can also rotate the plane of polarized light to an equal degree but in opposite directions. You know that. The properties of rotating plane of polarized light is known as optical properties. I repeat, the properties of rotating plane of polarized light is known as optical activity. Now friend, molecular formula. C3H6O3 represents two enantiomeric lactic acid as shown below. L-lactic acid, this minus minus, and plus minus lactic acid. Rotate the plane of polarized light toward the right hand side, that is clockwise. Rotate the plane of polarized light toward the left hand side, that is anticlockwise. Geometrical isomerisms. So here geometrical isomerism, you can see here this is the cis and this is the trans. Now types of optical activity: dextrorotatory plus older D minus. Rotate the plane polarized light to the right. Levorotatory new minus minus this older L minus. So this designation is new. This is the new. Levorotatory, rotate the plane polarized light to the left. Now friends, optical activity. In this slide, you can see here incident polarized light, simple cell, angle of rotation alpha, transmission light rotated. A solution of substance to be examined is placed inside the cell. Now sodium lamp, polarizer, plane polarized light, simple cell, plane is rotated, observed rotations alpha, analyzer, rotate to null. Angle of rotation is the angle degree by which the analyzer is rotated to get maximum intensity of light. It depends upon nature of substance, concentration of the solutions in gram per ml, length of the polarimeter tube, wavelength of the incident monochromatic light, and temperature of the sample. Now friend, a specific rotation alpha. It is defined as the number of degree of rotations caused by a solutions of 1.0 gram of compound per ml of solution taken in a polarimeter tube, 1.0 dm 10 cm long as a specific temperature and wavelength. The specific rotation is calculated from observed angle of rotations alpha as below. Alpha lambda is equal to alpha divided by L into C, where concentration alpha is specific rotation, T0 temperature of the sample, lambda wavelength of incident light, where sodium D line is used, lambda is replaced by D. Alpha observed angle of rotations, I length of the polarimeter tube in decimeters, C is equal to concentration of sample in gram per ml of the solutions. Chirality or optical activity discovery. French chemist Louis Pasteur discovered that crystalline optically inactive sodium ammonium tartrate was a mixture of two types of crystals which were mirror images of each other. Each type of crystal, when dissolved in water, was optically active. The specific rotation of the two solutions were exactly equal but of opposite sign. Pasteur discovery, Louis Pasteur's 1848, Sorbonne, Paris. This is the tartaric acid. He made sodium ammonium tartrate. You can see the crystal of sodium ammonium tartrate, hemihedral faces. Pasteur found two different crystals, mirror image. So Biot's results positive and negative. Now friend, chirality. An object which cannot be superimposed on its mirror image is said to be chiral, and the properties of non-superinsibility is called chirality. Thus our hands are chiral. Similarly, alphabet R, F, J are chiral and A, M, O are achiral. You can see here chiral object and achiral object. So molecular chirality and asymmetric carbon. Chirality in molecule is usually due to the presence of sp3 carbon atom with 4 different groups attached to it. Friends, such a carbon atom is called a chiral carbon or chirality center. The presence of a chirality center usually leads to molecular chirality. Such a molecule has no plane of symmetry and exists as a pair of enantiomers. Such a carbon atom is sometimes also referred to as asymmetric carbon atom. So a ball and stick model of compound CYWXYZ. The derivative of methanes where W, X, Y and Z are all different atoms or groups and model of its mirror image. So you can see the mirror plane. We may twist and turn the above two representation in any way we like, so long we do not break any bond. Yet they find that the two are non-superimposable. Therefore, they must represent two isomers, two enantiomers. Now friends, non-supermural image also called optical isomers. So Pasteur decided that the molecule that made the crystals, just as crystals themselves, must be mirror image each other, must contain a single type of enantiomers. Pasteur hypothesis eventually led to the discovery that tetravalent carbon atoms are tetrahedral, one half and a label tetrahedral carbon. Only tetrahedral geometry can lead to mirror image molecule. So square planar, square pyramidal or trigonal pyramid will not work. How to distinguish between enantiomers? Fisher projection formula represents the two enantiomers in two dimensions with the assumption that the two horizontal bonds Cy and Cw project toward us out of the plane of the paper and two vertical bonds Cx and Cz project away from us behind the paper. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.